to do our second presentation in our education series, and tonight is on Unity. So introduce himself and get us started.
I am not associated with Unity Technologies, unlike all the other presenters are associated with people who own that technology. Okay, so my presentation is on Unity 3D. Why? What? Why? What? No. Anyways, so this is a basic primer of Unity. So if I won't be mad if you none of this information interests you, and pardon my mess of leaving words there. But I had a couple things that needed to be touched on and a short time. So if you'd like to get the slides with embeddable links and some interaction, there's a QR code and the URL directly that can be able to view it. Even the people here live, I would suggest, be able to read what is already there. So the first question is why, and really it answers the question what. What do video game engines provide to developers of AR, VR, and in general? I'm not going to just read the actual board, but essentially what the answer is that game engines allow developers, both large and small, to quickly get up and running on a project. There are developed giant names like, I believe it was Ubisoft Montreal, that actually prototype inside of Unity for their games and then end up porting to their own in-house engine. So it's not like you have to ship whatever it is that you're making in Unity. There's people that actually use Unity as not for just games, but for like a base for maybe like a VR video player. Most of those are based in Unity, for example. What video games engines provide is your rendering, your networking, because a lot of those things are things you'd either have to build yourself or pay somebody to build. So essentially, when you're using a game engine like Unity, you've got a whole tech team behind you, and is able to provide you with many advanced technologies. I won't read the list of the built-in packages, you can see them there. But those are the major ones that are in basically any game engine. I'm not 100% sure whether I should go over what PBR rendering is. It's physical-based rendering, physical-based shading, that it tries to do its best to simulate what light actually does. That's not ray tracing. For pardon the dust here. For the game engines allow you to deploy on platforms after you've only developed once. It used to be that if you wanted to like release for a new for the Nintendo and the Super Nintendo or whatever, or any of the other systems, you'd have to make multiple versions of the same game. You'd have probably different companies making the same game over and over because they didn't have the proper tools. These are the tools that allow us to program once and then release it out into the wild on all. Maybe with a little bit of modification based on power, but that's the tools are also built into it that would allow you to target different platforms. There's a short list of AR and VR platforms. As we just heard an hour ago about Microsoft HoloLens and how easy it is to develop for it. They nest their SDKs not in just Windows, but in a game engine, and for good reason. Okay, so to explain the three rendering engines, well, there's actually a fourth one, but that's really super advanced. It's the custom scriptable render pipeline and that would be ill-advised to suggest so. So if you're making a game now, I would suggest not using the built-in renderer. I would suggest targeting for the universal render pipeline, previously known as lightweight render pipeline. It's performant. There's people that ported their game from the built-in renderer to the URP, and they were getting like 20 to 30% increase in frame rate and performance. But there are projects out there that are VR that you may touch, you may interact with, like VR chat, for example, is still, there's a lot of legacy engines or games and game tools that are still using some of the older rendering, but which the older rendering was primarily their Uber shaders. So it was like when Unity 5 came out, they put out this physical base renderer, but most likely those things are going to be people already dealing with their project that is in maintenance. That's like 5 or 6 years that they had their first release, and they most likely are not going to be upgrading to the newer versions of the Unity editor. So the other than URP that I would suggest would be the high definition render pipeline. That's for big teams. That's like a AAA kind of thing. You can use it, but to get full advantage of having every single one of the textures it demands, it uses like mass textures that are like very specific, but it's the most next gen high frame. If you want to get high frame rates, you go with URP. If you want to get high quality, you go with HDRP. And here's a chart. Sorry if it's blurry. I had it converted from an SVG. Yeah. Anyway, so if your project is already made, I really suggest against using the built-in render pipeline, unless the project that you're already is already in existence. So, and then of course this goes over the problems of the custom render scriptable render pipeline. Is that you'd have to basically do most of the stuff that would be tailored to on the asset store yourself. I think I missed something on. Okay, so among the other things of why you do use a game engine and platform deployment is the integration of SDKs. Like what was just shown an hour ago for the HoloLens, the engine was actually, they're using the rendering and basically piggybacking on to Unity. Among that is like, if somebody is making something that they're trying to share and try to sell, a lot of the time they use a game engine, and then that's for like the asset store. There's quite a few things that would 10 years ago have been a separate package, like a completely separate application, now is built into a game engine. I really want to get that across. Okay, so Unity has spent a long time trying to get the graphics up to a fidelity that is photorealistic. You can quickly take your assets like these. Let me just show you this video. Okay. So, screen. Okay. So, as you can see, the visual fidelity that looks exactly like a real car. It's not. And what they used to have to do like 5-6 years ago was they would like be able to do like maybe 1 or 2 screenshots for themselves, and then they would send it off to a render farm. Sorry for the low resolution, but but yeah, they would send it off to a render farm, and with a game engine, they could just render this real time. This is all being done real time. A nearly perfectly photorealistic render. Let's see. Full screen there. Okay. Anyway, so down here it shows an example that they're actually using photorealistic rendering in Unity to simulate with all the things that you would need to basically use machine learning to program artificially intelligent vehicles, autonomous vehicle training, all of it. Because they have to have so many hours before they'll be able to put it on the road. The fidelity is so close to reality that they can just render directly. Yeah. But that's directly in let's say virtual reality air quotes, but okay. So things you need to know about Unity networking. They acquired MLAPI, the mid-level. So it's a mid-level language instead of, well, they say mid-level, it's actually a high-level order API. And they previously had UNet, which was a absolute nightmare. I'm not an employee of Unity technology, I can't tell you, it's like, that was really, really bad. Anyway, so there's docs here for connecting to the Discord, and anyways, you can migrate now from UNet to MLAPI. Previously, people had been using both Mirror and Photon. Mirror was like what was created after UNet was decided to be deprecated. So they somebody created their own UNet implementation. Previously, most people use Photon or Proton. I think there's some other name attached to that. Okay, so the reason I was giving this presentation was that other stuff was just really an add-on to talking about visual scripting. Visual scripting is the thing that makes the difference, had made the difference for a lot of people between it and Unreal. Unreal Engine is in C++, is programmed in C++, which was very hard for a lot of programmers to go to learn. It's quite a bit more deep, requiring a lot of more math and those types of things. It was harder. The reason that Unity uses C# and that why Unity is the thing that people use over Unreal a lot of the time was the reason why Unreal created blueprints. And that was the one thing that people were missing out on, was visual scripting inside of Unity. So they acquired Bolt and Bolt 2 from their developer. They didn't actually acquire the company, they just bought the actual software from them. Anyway, so this is actually built into Unity. It's free. I think it might be even a default package now. Don't quote me on that. Anyway, so visual scripting allows people who are not all that technically inclined when it comes to programming. Like me, I'm learning disabled, so I had to. I was waiting for Bolt 2. I was like, okay, I knew that eventually Bolt was going to be acquired by Unity, so I even had another visual script, more than one visual scripting engine that I gave the license to a friend. I didn't even use it. Because I knew what was going to be acquired, which was Bolt. Bolt 2 would actually generate the code live, and that was what mostly interested me. Because looking at like a page of code and like trying to get all the syntax right, I'd been burned multiple times with things on the Unity tutorials just being wrong. Like there was like I copied and pasted some C#, and it was actually most likely just JavaScript that had been transformed into C#. And it was just wrong. So I like multiple times got burnt. So what I wanted was like a visual scripting engine, because being a much more visual person, could actually learn this. I've done some videos, tutorials on this, and I'm actually able to create some basic scripting commands. And that's predominantly what Unity is actually trying to do with visual scripting, is give people who don't have the skill or find typing in code daunting, a easier way of getting in there. Like, I mean, like me, as I'm an artist, so if I need to do something basic in Unity, I would have to go to my programmer on a project to do even the most basic thing. But with visual scripting, I can do those simple things that I wanted to and actually there could be that your programmer can give you access to their code. Like to be able to, you could actually create custom nodes that would allow your artists, your designers to do tests on your code. Anyway, so as you can see here, this video, I'll go through the whole thing. Let's see. Anyway, so this is them working with the code. You can see that their ship shooting behavior. Okay, so it's going to flow through here. And this is a custom behavior that they have. And so instead of having to have the programmer modify like the time or whatever, they can just, oh, right here, live. Back to percent. Right. Okay, so what I suggest if you're interested in digital scripting is watch this video from CG, or read this page from CG Cookie. I got quite a few examples here from industrial design and prototyping, visual scripting for just your team, and an introduction to it. These